Okay, so this is a set of notes on medians and altitudes in triangles. So a median, it's really awful. Median is if I'm given a triangle. So there we go, we have a triangle. And I find the midpoint of one side. There's the midpoint, and I connect one vertex to that midpoint. There we go. This is called a median. All right, an altitude is similar. If I have a triangle, and I draw a segment perpendicular to one side from a vertex, I get an altitude. So this one connects to the midpoint. This one is perpendicular to the vertex. And that's kind of the difference between medians and altitudes. Alright, so we're going to use these to create two more of the centers of a triangle. So in the last video we got a circumcenter. And we got an in-center. And the circumcenter was made from the perpendicular bisectors and was equidistant from the vertices. The in-center was made from the angle bisectors and was equidistant from the sides. Today we're going to kind of look at this with regard to medians and altitudes. Okay, so the first thing that we're going to look at is what we are going to call a centroid. Okay, so if I'm going to label this a centroid. Alright, so what I do is I need a triangle. So let's build the triangle here. There we go. Some arbitrary triangle. And I'm going to build the three medians. So in order to build medians, I have to have midpoints, right? So I'm going to construct midpoints. And then what I'm going to do is I'm going to construct three medians. One here, one here, and one here. Okay, so this point in the middle of them is what we call the centroid. Now, this is significant because this is the center of mass of this triangle. So if you were to cut this triangle out of this page and you were to try to balance it, it would balance perfectly on that point. So where the three medians lie, we end up with what we call the centroid. Okay, so we're going to start a new sketch and we're going to get this last one, which is what we call the orthocenter. Okay, so the orthocenter, again, we start with some arbitrary triangle. And now we're going to build three altitudes. So I want to go from that vertex to that side, and I want to construct a perpendicular line. Okay, so that there is an altitude. Okay. We're going to go from this point to this side, and we're going to construct a perpendicular line. Okay, and again, this one here is also an altitude. And then finally, we're going to construct a third one from this vertex to that side. So let's get rid of that. There we go. Alright, so the vertex to that side, and we're going to construct a perpendicular line. And that one right there is the third altitude. Now, it's kind of bunched up there a little bit, so maybe we'll move the triangle a bit so you can see this a little better. There we go. And you can see that these three lines are all intersecting at a single point. And that point is what we call the orthocenter. Okay, and for better or for worse, there is not much significant about the orthocenter. It's a pretty, other than the fact that it's where the three altitudes line up, it is pretty insignificant in the whole greater scheme of things. So, we now have all four centers of a triangle. The circumcenter, the incenter, the centroid, which is the center of mass caused by the medians, and the orthocenter, which is a pretty useless point, but it is caused when you have the intersection of the three altitudes. All right, so there you go.